Hello, I am Alejandro Delgado, and this is my lab report on oscillations. Oscillation occurs when an object undergoes motion around an equilibrium point. It occurs through several periods where an object swings back and forth, converting potential to kinetic energy. The purpose of this lab is to analyze how energy is transferred inside a system from potential to kinetic to spring within a given period of oscillation. We are analyzing a spring system in this lab that oscillates in both the x and y directions. Some relevant physics principles to get started with before we actually get into the actual experiment. When everything is contained in the same system, the change in energy is equal to zero. This is because all the changes of energy occur within the system that is defined by us, which I'll get to later. That meaning that there is no external work or heat being given off, so the energy change is zero. The combined kinetic, gravitational, and spring energy will give us the total energy in the system. When the spring force and the gravity force are the only forces acting on an object, F net equals F spring plus F gravity, which causes the period of oscillation, which is defined by 2 pi times square root of m over k. The initial conditions for this video that we analyzed is that the spring started off at negative 0.711 meters and it has a mass of 0.402 kilograms. To find the spring force, we had to manipulate the period equation and measure how long it took for the spring to get back to the same place it was after one whole loop. With this, we got that the spring constant was 9.64175 Newton over meters. To calculate the rest length, we had to use the net force equation, which was able to give us that the resting length was 0.2831. The initial condition of the system is that the system contains the block, the earth, and the spring, and for the sake of this experiment, there are no external forces acting on it, even though in real life there are probably some like wind, drag forces that act on it. So when coded with all the initial conditions into Python, the energy is shown to be conserved between potential and kinetic and spring. As you can see here, when the dips and the peaks are all added together, they equal the total energy line, which is zero, or a change in energy line rather. The spring below in the video does little oscillations that appear like orbits, and they go in both the x and the y direction. So think kind of a ring going around that in each direction. Some sources of error are the miscalibration of the tracker mass, inaccuracy of the spring length, because we use different videos than in the video described where all the information was given to us. And also, we did not account for the mass of the spring in this scenario. We are only accounting for the mass at the end of the block, it seems. So this will definitely change our answer a bit if we were to get real answers. What does it mean? As shown in the previous graphs, the peaks and dips always add to the total energy line, meaning if the energy principle is satisfied. The periods for the x direction and the y direction are essentially the same, as oscillations do not necessarily depend on the displacement of the block. Remember I mentioned earlier that the equation for period is t is equal to 2 pi times square root m over k. Because x or y or displacement at all does not appear anywhere in this equation, it is safe to say that it has very little to no effect here. The reason that these values are different here is probably because of some source of error or miscalibration with the tracker clicker. So yeah.